Hello everyone, my name is Pratice. Today we will discuss about sensorless MTPA based vector control IPMSM drive. Basically we are going to cover the sensorless methods, which are extended Kalman filter, and another is MRAS observer. This is the complete drive arrangement with MRAS observer. In this we have a vector control arrangement. Here another is MTPA arrangement, which we are going to talk about in next slides. This is our MRAS observer, which will provide the estimation of speed and angular position theta. Similarly, this is the arrangement for extended Kalman filter. This arrangement is similar like previous arrangement, except the method which is going to give us the rotor angular position theta and the speed. Let's first of all discuss about the construction of PMSM motor. Here we have two types of PMSM motor. First is surface magnet type motor and another is interior magnet type motor. As name suggests, for the surface magnet type motor, the magnets are glued on the rotor, and for interior magnet type, the magnets are buried inside the rotor. So due to this difference in construction, the another difference is there, which is difference in their inductance. Let me tell you the one thing, that the permeability of the air is the same as the magnet. So for the D axis and Q axis, the effective air gap is same for D and Q axis. So the inductance will be same for both of them. And for interior permanent magnet type, so you can notice here that the total effective air gap for the D axis is more compared to Q axis inductance. So the air gap for D and Q axis is different. So it will have the Q axis inductance is more than the D axis inductance. Let's discuss about the vector control of IPMSM drive. In this, the vector control basically used to decouple the flux component and torque component in order to control individually. And basically D axis current component will control the flux component and Q axis current component will control the torque. For the transforming from the ABC reference frame to DQ reference frame, the below matrix is used. Now this is the maximum torque per ampere method, which is basically optimization problem, which is formulated like minimize the current with respect to torque. So it is basically, it will give the combination of D and Q axis, it will give the minimum combination of D and Q axis current component for given torque. So how we are going to get the current references? So here we have the torque equation, where the IQ is Q axis current component, ID is D axis current component, and lambda PM is flux linked by permanent magnet machine. And here LD and LQ are D axis and Q axis inductance, and P is pole pair. So dividing the current in two parts, which are our ID and IQ, and if we combine together, we can get the total I. Here the phi is the angle between the resultant current and D axis current component. So if we put in the equation number 1, we can get the equation number 2. Okay, so for maximum torque per ampere condition, we know that we have to differentiate with respect to phi is equal to 0, and we can get the equation number 3. And by doing the basic trigonometric manipulation, we can get the equation number 4. So we can rearrange them in the manner of ax square plus bx plus c is equal to 0. So if we want to solve that equation, we have to apply the formula, which is minus b plus or minus under root b square minus 4ac divided by 2a. Okay, so we will get the ID. Okay, and if we put the ID in equation number 2, we can get the equation number 7. So now we will form the lookup table for IQ, ID and torque. So whenever we get the reference torque, it will produce the minimum combination of IQ and ID. So we have equation of ID and we have here another equation of torque. So if we increase the IQ with the step of 0.01 to 14, we will get the value of ID. Okay, and similarly in the torque equation, if we increase the IQ in similar manner, we can get the torque as well. So now we have three values for IQ, ID and torque. So now we can form the IQ, ID versus torque. Okay, so here we have torque on the x-axis and IQ at the upper side, and at the bottom side we have d-axis.